Next up, we have percentages. So this will include stuff like percent of increase, percent of decrease, or percent of change, that type of stuff. So let's get started. The first thing is that 1% is equal to 1 over 100 or 0.01. So whenever you see a percent sign, that means you can just make it a fraction by putting it over 100, or you could move it two decimal places over, two decimal places to the left. Alright, for our first equation, we have the percent of equation. And that's going to be new equals original times percent. Here in this example, I bought Elden Ring on sale for 70% of the original price. If the original price was $60, what is the new price? Here it says that they bought it for 70% of the original price, so that's going to be our percent. And then it says the original price was $60, so that's going to be our original. If we go ahead and plug that into our equation, new equals original times percent, it's going to look like this. New equals 60 times 70%. Now we're going to go ahead and convert that percent into a decimal. So we're going to move two decimal places over, and we get that it's 60 times 0.7. Now you can also do 60 times 70 over 100 if you wanted to. And then 60 times 0.7 is just 42. So the new price is $42. Here I am in decimals, and if you don't want to convert it to a decimal or fraction, you can actually use decimals for percent of equations. So here, we want to get 70% of $60. So if you go ahead and type in 70, and then the percent symbol, the of instantly pops up for you. So now all you have to do is type in 60, and we get that 70% of 60 is 42, which is the exact same as what we got. Then for our next equation, we have the percent of decrease equation. And this is gonna be new equals original times 1 minus the percent. Now the important thing to notice with this equation is that you're always going to be subtracting from 1. This means that that number inside the parentheses is always going to be smaller than 1. So if they ever give you the equation and you see that the number inside the parentheses is less than 1, you should instantly know that you're working with percent of decrease. So here in our example, I bought Elden Ring on sale for 30% off the original price. If the original price was $60, what is the new price? Now the keyword here in this new example is that it's 30% off. In our last example, it was 70% of the original price. But now it's 30% off the original price. That means we're going to have to use the percent of decrease equation. Here 30% is going to be our percent, and our original price is $60, so that's going to be our original. If we go ahead and plug that into our equation, new equals original times 1 minus percent, we get that it's going to be new equals 60 times 1 minus 30%. Now if we go ahead and convert that 30% to a decimal, we get it's going to be 0.3. 1 minus 0.3 is 0.7. So we get that new is equals to 60 times 0.7, and 60 times 0.7 is 42. So the new price is $42. Here I am in decimals, and if you wanted to type this in decimals without converting the percent into a decimal or fraction, it would look like this. So here I went ahead and typed in our equation. Our original was $60 times 1 minus 30%, and now after the of, you're gonna put 30% of 1. And then you get that your answer is still 42. Then for our third equation, we have the percent of increase equation. And that's gonna be new equals original times 1 plus percent. So the difference between the percent of increase and the percent of decrease is that when you're increasing, you would add, and if you're decreasing, you would subtract. Once again, the important thing to notice with this equation is that you're always adding 1. That means that that number inside the parentheses will always be a number greater than 1. So once again, if they give you an equation and you see that the number inside the parentheses is greater than 1, you should know that you're dealing with percent of increase. Alright, so here in our example, defeating Rykard gives you 130,000 runes. The Golden Scarab increases your rune gain by 20%. How many runes would you get by defeating Rykard and equipping the Golden Scarab? Here it says that it increases your rune gain by 20%, and since we're increasing, we would use the percent of increase equation. And then it says it increases by 20%, so that's going to be our percent. Then it says that it gives you 130,000 runes, so 130,000 will be our original. If we go ahead and plug that into our equation, new equals original times 1 plus percent, we get that new is equals to 130,000 times 1 plus 20%. If we go ahead and convert that 20% into a decimal, we get that it's going to be 0.2. 1 plus 0.2 is 1.2, so our equation will look like new equals 130,000 times 1.2. And 130,000 times 1.2 is 156,000, so you would get 156,000 runes. Here I am in Desmos, and once again, if you don't want to convert the percent into a decimal or fraction, this is how you would do it in Desmos. I have our equation here. Our original was 130,000 times 1 plus our percent was 20%, and once again, it's gonna be 20% of 1. Now we get that our answer is 156,000, which is the exact same as what we got. Then for our last equation, we have the percent of change equation, and this is gonna be percent equals new minus original over original times 100. So here in our example, defeating Rykard normally gives you 130,000 runes. After equipping the golden scarab, you would gain 156,000 runes. By how much does the golden scarab boost your rune gain? So here it tells you that it normally gives you 130,000 runes. So that would be our original. And then it says that we would gain 156,000 runes after we equip the golden scarab. So that would be our new. However, this time it doesn't give us the percent. So that's what we're looking for. And since we're trying to find how much percent it changed, we're going to use the percent of change equation. So here if we go ahead and plug that into our equation, percent equals new minus original over original times 100, we get that percent is equals to 156,000 minus 130,000 over 130,000 times 100. Alright, so this is what our equation looks like after everything is substituted in. I had to go to another slide because I ran out of space. First things first, 156,000 minus 130,000 is 26,000. So now our equation will look like this. Then we're gonna do 26,000 divided by 130,000, and we get that it's gonna be 0.2. Now we're gonna multiply 0.2 by 100, and we get it's 20. So our answer is going to be 20%. The golden scarab boosts our rune gain by 20%. Here I am in Desmos, and this one is honestly just super easy to just put into Desmos. You just have to know the equation. Here I do have the equation for us, and let's start plugging things in. Our new is going to be 156,000 minus our original, which is 130,000 over our original, which is once again 130,000 times 100, and we get that our answer is 20%, so it's the exact same. Alright, here I have an SAT question example. The function f gives the value in dollars of a certain piece of equipment after X months of use. If the value of the equipment decreases each year by p% of its value the preceding year, what is the value of p? Now that was a whole big paragraph just to tell you that it's decreasing. This is really all that we care about. Since it's decreasing, we know that we're going to be using the percent of decrease equation. So new equals original times 1 minus percent. Now you also didn't even need to read that, because if you looked at the equation up here, the number inside the parentheses is less than 1, which also means that it's going to be percent of decrease. Alright, then the question asks us what the value of p is, and here it says it's decreasing by p%. So we want to know by how much percent are we decreasing each year. Now if we look in our equation here, we see the word percent is right here inside the parentheses. Now we also see that inside the parentheses is 0.64 up here. So what I'm trying to say here is that you can put 0.64 equal to 1 minus percent because they're both inside the parentheses. Now we just have to find 1 minus what gets you to 0.64, or you could just solve for percent, and you get that percent is going to be 0.36. So 1 minus 0.36 equals 0.64. And then since we want it in percent, we're going to go ahead and move the decimal point right 2 spaces, or we're going to multiply it by 100, and we get that it's going to be 36%. So our answer is C. Alright, then I have the second example here. 210 is p% greater than 30. What is the value of p? Now the important thing to notice here is that it says it's p% greater than 30. So we're starting off with 30, then we multiply it by some percent, and we end up with 210. So if we go ahead and plug it into the equations we've been using, 30 would be our original value, and 210 would be our new value. Now since we're trying to find the percent, that means we're going to be using the percent of change equation. So that's going to be percent equals new minus original over original times 100. If we substitute everything in, 210 is our new and 30 is our original. So look like that. 210 minus 30 is 180, and then 180 divided by 30 is 6. So now we have the equation percent equals 6 times 100. 6 times 100 is 600, which means that the value of p, or the percent, is going to be 600%. Now it's super important that you do not mix this up with the percent of equation. If the question had said 210 is p% of 30, then you would use the percent of equation. However, here it says it's p% greater than 30. That means you have to use the percent of change equation. Okay, that's gonna be all on percent. So you have 4 equations that you need to know. The first one is going to be the percent of equation. The second one is going to be the percent of decrease equation. The third one is going to be the percent of increase equation. And the fourth and last one will be the percent of change equation. Once you get all 4 of these down, you're basically set on everything that you need to do percent-wise on the SAT. Good luck studying, and I'll see ya.